Before we are able to talk about our next method, which is solving by factoring, we need to review a couple of things, or kind of talk about a couple of things, one of those two things being the zero product property. So first I want you to remember that 0 times anything is 0. 0 times 10, 0. 0 times negative 2 billion, 0. 0 times anything is equal to 0, which leads us to our zero product property. It says in algebra, if AB equals 0, so A times B equals 0, then either A equals B 0 or B equals 0. In other words, when the product of two or more factors equals 0, one of those factors must equal 0. So we're going to use that in order to find our zeros. In fact, we have done this before. We have done this already. We're just going to kind of add a layer to it. And what we're looking for are our zeros. We're looking for the values that make the equation true, which right now makes it equal to 0. So let's take a look at some examples where we're just using the zero product property. So first, notice that what I have here, I've got two factors equal to 0. X minus 2 times x plus 3 equals 0. What the zero product property allows me to do is come in here and say, well, if x minus 2 times x plus 3 equals 0, then either x minus 2 is 0 or x plus 3 is 0. So I can set each factor equal to 0 and I can solve. So I get x equals 2 or x equals negative 3. Those being my two zeros or my two solutions to this equation. Notice if I plug them in. If I plug in 2, I'm going to get 2 minus 2 is 0 times 2 plus 3 is 5, so 0 times 5, 0. And if I plug negative 3 in, I'm going to get negative 3 minus 2 is negative 5 times negative 3 plus 3, 0. I get negative 5 times 0. That gives me 0. So I'm finding my two zeros, which is finding my two solutions, my two roots, my two x-intercepts. Those are all kind of saying the same thing. Now we had gotten in the habit of saying, well, I'm just going to take the opposite. So if it's x minus 2, it's 2. And if it's x plus 3, it's negative 3. But I need to be careful about that. Look at example 2. Notice this time I don't just have x minus 1. I've got 3x minus 1. And I don't have x plus 5. I have 2x plus 5. Just taking the opposite doesn't work in this case. So I'm going to do the whole zero product property here. And I am going to say, if I've got 3x minus 1 times 2x plus 5 equal to 0, then either 3x minus 1 equals 0 or 2x plus 5 equals 0, and I need to solve each equation. So I've got two-step equations here. I'm going to add 1 to both sides, and then I've got to divide by 3. 3 times x, the opposite of multiplication is division. Notice my answer is a fraction, and I'm going to leave it as a fraction. So that's x equals 1/3. I neatened it up for us a little bit there. Okay, to solve my second equation, I've got 2x plus 5 equals 0, two-step equation. So first I take care of my addition and subtraction. So subtracting 5 from both sides. And then dividing by 2. And yes, again, it's a fraction, and I'm just going to leave it as a fraction. Now, as a side note, if I wrote negative 2/5, if I rewrote it as negative 2.5, that's fine. But if you rewrote 1/3 as 0.33, I'm going to be a little bit not okay with that one because you have to round. The 1/3 is a repeating decimal that goes forever and ever and ever and ever. So I want it as a fraction. I will not take it as a decimal unless you're told to round. Example 3 and 4 for the zero product property we are going to do in class together, but I do want to go ahead and in this same video talk about our standard form. So we're going to finish the at least one more example here, and then come back and do these two in class together. So our standard form. We've talked about standard form, ax squared plus bx plus c equals 0. And when we are solving in all the rest of our methods, we need it to be in standard form in order to solve. So when we're taking the square root, we don't need it in standard form. But when we're doing our factoring method and our quadratic formula method, we need it in standard form when we start. So here I'm just going to practice putting it into standard form. So here's what I mean by it's not in standard form. I've got an x squared, I've got an x, I've got an x, and I've got a constant. What I want is 0 on this side. I want everything over on one side. Notice I'm not isolating my x squared because I also have an x. So I've got to get it to standard form so I can do something with it to finish solving. So I'm going to start here by getting my x's together. Because I'm crossing the equal sign, I need to use my inverses. So I'm going to subtract x from both sides. Notice I lined it up with my like term. So I lined it up underneath the term that has the same variable, same exponent. And then I'm not done. I still want to get rid of that 6 because I want a 0 on that side. Notice I have no like terms to the 6 on the left-hand side, so I can't actually add them. So I'm just going to do 3x squared plus 3x minus 6 equals 0. And that's our standard form. I'm going to save example 2 to do together in class. Again, these two things, the zero product property and getting it into standard form, that's kind of a prerequisite for our next method.